close this. Okay. So we are going to look first at an implementation in German, and we are going to take the Kölner phonetic on the side and try to just understand, maybe not like go through every single detail, but understand Wikipedia. Yes, we switched to tab. Oh, okay. So let's do this. And I don't know where there was a window, but that's fine. So that's the Kölner phonetic. So basically, how it works that like we have a characters map, which is a few regular expression followed by what they should be replaced with. So for example, see here, so this, and I think it's an interesting video to actually go through what regular expressions are and how they work. And I'm going to restart the timer, delete, start again. Oops, no, delete. Yeah, okay. So it's an interesting opportunity to look at what regular expressions are and how they should be replaced. So here, for example, we say C followed by A, H, K, L, O, G, R, U, or X. Okay? So here, this, what was the name of this? In English, circumflex, caret. Okay, yeah, I was thinking about caret. So this caret symbol here, let's start with the beginning of the slash here. So when you declare a regular expression, you use a character and you use it again at the end, and it just like tells the program that this is the beginning and the end of a regular expression. Usually the character used is slash, but if I'm correct in PHP, you can use any character. Like the first character will be looked as being the last character. It can be convenient to switch what character you are using. For example, if we want to have a regular expression that uses slash, it may be convenient to not have slash here and at the beginning. So the caret, the first one, when it's at the beginning, means it has to be the beginning of a word, of the string that we are trying to match. So here we say, like, if something starts with a C, and then when we are looking at the brackets here, we say anything that starts with C and followed by any character in, it's called a character class, that is A, H, K, L, O, Q, sorry, R, U, and X. And the parentheses here mean that we are going to try to capture whatever is here. So what we're doing here is that we are ensuring that this is a C before that. And if we look here, C, in the initial sound, so it has to start, it has to be at the beginning, and then we have a list. And otherwise, actually maybe there is an implementation problem here. Is there another C? Yeah, there is another C here. So those are the two rules. So one gives an 8 and one gives a 4. And those are the two rules which are here. And since it says in the initial sound, it has to be at the beginning. And so here, this capturing group means like if your regular expression is successful, you will have a variable that will contain whatever has been matched here. So for example, if it's a K, it will contain a K. And here we say you replace the C, so because only the C is not taken in the capturing group here, and you replace it by 4. So if you are dealing with regular expression, one of the cool things you can do is you go there on regex101.com. Here the slashes are implicit, so you don't put them here. And then, for example, if I say Carolina, it doesn't match. But if I say Carolina, it still doesn't match. Why? Oh yeah, because it's this one is case sensitive. So one of the things that we will do is like to make everything lowercase to simplify everything, because it's a phonetic index, and I actually don't know of any language where using an uppercase changes the pronouncing of a word, and it's actually not the case in German. So here we have this, and again I'm going to do it with a K, like it doesn't work. And here you can also tell that there is a full match. So the full match is what did make this regular expression like find something. And the group one is what's between parentheses. And again, like I said, if I move this parenthesis to the left, I can see that suddenly I'm matching everything. I can also, for example, capture more than one element here. And I can say that this character class can be repeated any number of times. So that would be a star. No, it could be a plus. So it means plus means at least one and up to whatever. So that's exactly what it says here. So this site is very convenient because it breaks down your regular expression for you. And for example, here I see that it's matching all this. Not necessarily what I want, but I'm showing it. So, let's go briefly through the other rules. Then we have the rules for P, and here we say P before H is 3, but here we have another rule here, P not before H is 1, so that's this first thing. So here we have another caret, and within a character class, which means like within those brackets, the meaning of this caret is not beginning, it means it's a negation. So it means anything but H. Similarly here, it is anything but A, H, K, L, etc. So after we apply a lot of different things, and we also remember that at this stage where we are here, C, I'm just checking this, meaning also not after S or Z. Not sure that there is not a bug here. So after S or Z, so it's a 4. But here, if I have S or Z, I should test that. So let's say I have a word that is like psi. Okay. And psi should be replaced. So first I'm going to process the S. So the S says 8. And after S or Z, oh yeah, true. Okay, it's not after S or Z here, because here I'm replacing my C first. So that's one of the few challenges here, is to put all those regular expressions in the right order, so like they apply without conflicting with one another. So here we have a lot of different things with a few comments which are just to make sure that we are matching this table here. And actually, like the last rule is like encode letter by letter according to the conversion table, which is this. And then remove all digits occurring more than once next to each other. And this is here. So this is a more interesting regular expression. So it says here, like capture any digit, and if this digit is repeated again at least one time, then you replace all that has matched here only by the capture group, which is the first digit that you've encountered. So, for example, if this encounters something like this, it will give something like 0, 0, like this. And if I remove and if I put this in, I will get this. Okay. And then it says remove all 0 but not the leading one. So basically, if the word is starting with an L or a J or a Y or a U, you keep it at the beginning. So you keep the 0 at the beginning. So basically I'm saying this is a character group, and this says if I want to capture a character that is not the caret, meaning the beginning. So not the beginning, and then I remove everything. And so then the rest of the algorithm is fairly simple once we understand this table. So the main function is called get phonetic index. We are gonna work with an str to lower, which means that we switch everything to lowercase. Then we remove the diacritics. So diacritics are just accents. So for example, instead of having something like this, we are gonna suddenly understand with this and with this. So it might be interesting, since whatever happens, every vowels end up being the same in German. But otherwise, like, those accents are changing the pronouncing, so maybe it shouldn't be always done like that. And then we strip the punctuation in the word, but we expect this word to be a word and not a string. So this is actually kind of more of an overshoot. And so if we find any space, so this means space in regular expression, we replace it by nothing. And so we keep the word. If the word is empty, we return nothing. And then we have this that get keys and values from map. I don't remember what this does, but basically I have an array with ints, things that goes in and how I should replace them. And we are not using here preg replace, which is the same rule as here, because we don't want whatever is like overlapping patterns like this. Otherwise they don't get properly replaced because they don't match what we expect. So we have this thing called multi-replace, and basically we call preg replace on every word until it doesn't change anything. So this specific thing here that we can't make a single call to preg replace, I think it's the one of the bad thing about performance that we will get here. Why? Because like preg replace with many patterns is likely to be a bit optimized. That's one thing. And the second thing is that like we call this regular expression replace many times, like at least 2 times if there is anything that changes. So it's we call it at least like I think 1 extra time per matching rule. So if you use regular expression, the key thing that you need to memorize that they usually are quite slow compared to other things. And so they are a powerful tool, but a tool that costs a bit of resources. So it means that if you expect every user on your platform to run 1,000 of them, that's already quite some load. And basically, if you need, for example, to have something like that to search in a database, you need to store the results and refresh them time by time, but it can be quite slow. Yeah, and actually this function here is just keeping the keys at some point and then the values, and we want to make sure that they have the same orders because we are gonna like then process these 2 arrays here as planned. So here we have a first implementation for the German, and we also have tests for that. Let me look for the tests. The tests are here. So basically, I have a few words like Kartoffeln. It means like a potato, plural potatoes, I guess. Zufällig, I forgot. Kompliziert means complicated. A lot of different things here, and we check that everything goes out how we expected. So basically this project only have this class which is meaningful. I just created this small project, so if you wonder how to create a library for Composer that you can install after, just run Composer in it. You decide that you are doing a library and you start with a fairly empty shell, and then you do a bit of configuration, namely like explaining that whatever class is in SRC should be considered as prefixed with this namespace, and same thing for test. Okay. So I also installed already PHP units and PHP check style, and I don't actually need PHP check style. I'm going to remove it. So here, what I would like to display now is that so I can run my PHP unit things, and it doesn't work because it doesn't found a class transliterator. So transliterator is a class that is available with PHP if you have the international, namely INTL module installed. But basically, that's not something that is on the basic distribution for Mac. And rather than trying to fix all this, I'm gonna hack this. So I'm gonna use this thing. So I'm gonna use a Docker container that already contains some Apache version. So the name of this Docker container is Pensero /Apache PHP. I'm gonna give it the name PHP test, and I'm gonna run a batch inside it. So I'm gonna split my screen, and I'm gonna do this from here because I prefer always to run this kind of terminal here. Oh yeah, Docker is not running. I can launch it, it's no problem. So the cool thing is that I'm gonna start this container. It was already set up. PHP environment, and so I just need to run it, and my code will be able to run from here. So Docker here is still starting. Like when we see the small bricks here, it means that it's loading. Okay. So we have started the bash session. So we are right now inside of the Docker container, but we still have all our files, and so I can manually call the PHP unit version I've installed, run it, and ta-da! It works. So as one of my good friends used to tell me, if you have never seen a test failing, you should not trust that it works. And so now I've seen it failing, so I'm pretty happy with that. So I'm gonna init Git repository. I'm gonna check so whatever's here, so I can add vendor to some git ignore file. Okay. All the rest needs to be added, so git add.git ignore composer JSON composer.lock src tests git status add initial commits working German implementation. Oh yeah, booyah. Oh, here we are. Okay, so we have the first Git version here, and